for revision at home.
Yeah, about the chemistry at your home or at your school.
I continued answering past paper questions. I have done most of them.
Most of them. From which years to which year?
I started from 2019 to 2023.
Okay, so which means you attended most of the question from these years.
Yes.
So where did we?
But there is one question like
Please tell me where did we leave last time? At which topic? Did we complete the alkanes reactions?
yeah, we finished alkane.
Okay, we did alkanes. Did we start the alcohols? Let's start with the alcohols then. What is the functional group of the alcohols?
They have the OH.
Sorry? They have the OH, yes. Okay, I have received the question. You have sent me on WhatsApp. So yeah, for the alcohols we say that the functional group is the OH. That's functional group for alcohols. Now we can name some of the compounds of the alcohols depending upon the number of carbon atoms it contains. If there is one, so we will call it as methanol, and the formula will become CH4. This is the molecular formula CH4, and its structure formula will be represented by CH3OH, and its display formula will be represented by this structure. I hope these structures are clear. This structure is clear to you.
Yes.
Okay, then likewise we can keep increasing the number of the carbon atoms, and so the name will be, vary on the basis of the carbon atom. It will become ethanol, and in this compound it is propan-1-nol. The name is slightly different here. It is not just propanol, it is propan-1-nol. What is the basis of this number 1 in this name?
That the OH is attached to the first carbon atom.
The first carbon atom, yes. And the first carbon atom, can it be the left one as well?
Yes.
Yes, good. And same goes for butane-1-nol. What other isomer can I make from the butane-1-nol? Which other isomer can I make from this butane-1-nol?
As in like butane-2-ol.
Butane-2-ol, yes. Good. Butane-2-ol is possible. Is there any other isomer?
I don't think so.
There is another isomer in which you have to rearrange this chain. You have to change the arrangement of these carbon atoms. Like if I keep this intact in the same way, COH, but then I will change the other part, it will be like this. Isn't it so?
Oh yes.
What shall be the name of this isomer? Yes, Anya, what name will you give it to it?
Not too sure.
Basically, you can tell me, like, so that I can keep moving instead of waiting for a long time. All right. The name of this compound can be given on the basis of this side group present here, and then we have to give the number of the carbon which is bonded to OH. So which number will come first, and what will be the order of the numbering, from right to left, or it will be from left to right?
It will be from right to left.
Yes, good. It will be from right to left because this functional group is has more priority as compared to the side group. So we'll start the numbering from right to left. So this will be our numbering. Can you now give a name to it?
Would it be 2-methyl butyl 1-ol?
2-methyl prop. This is prop. There are 3 carbon atoms.
Oh yeah, prop 1-ol.
Prop 1-ol. Alright. Sorry. 2-methyl propane. It should be propane, not prop. 2-methyl propane 1-ol. Alright. That's the name of this molecule. You can take a screenshot of this.
Yeah, I did.
Okay, good. So that's how we can get some structure. Also give names to these molecules. Now moving forward, we have some of the reactions of the alcohols. The first reaction here is the oxidation of the ethanol. So basically you have studied in the previous topic about the oxidation of the alcohols. What kind of products, which products are formed when we oxidize the alkenes or alkenes? Anya, which product is from this reaction? Carbon dioxide and water. So basically we can get the same products when we oxidize the alcohol compounds. So here this one is ethanol, and when it is oxidized with the oxygen, you will again get the same products, carbon dioxide and water. But the only thing here is that you have to balance the chemical reaction accordingly. So that's the only practice you have to do. So here this is the oxidation of alcohols, and you can change the compound of the alcohol. You can also take propanol instead of ethanol, C3H, it will become C3H7 H7OH. That's the propanol. Or another way you can also write CH3 CH2 CH2OH, and then react it with the oxygen. You will again get carbon dioxide plus water, but you just need to balance the chemical reaction. Is it clear?
Yeah.
All right. Then basically ethanol is considered as a biofuel. Biofuel are such kind of the fuels which are extracted from the biological sources such as sugarcane or corn, and these are basically used as in our energy productions, and especially in the vehicles and factories, as like these kind of the industries. So we use the biofuels, this because some questions do come from here, the use of the ethanol especially. So ethanol is considered as a biofuel. Then on the other hand, the fossil fuels are considered as the non-renewable resources by fossil fuels. Like these fossil fuels include coal, natural gas, and petroleum. These are considered as non-renewable resources, whereas ethanol is considered as a biofuel and it can be extracted from these kinds of the vegetables, and we can grow these vegetables as much as we can. That's why biofuel is a renewable resource. Biofuel is a renewable resource. Is it clear?
Yes.
All right. Now we have discussed the oxidation of the alcohols. There is another kind of the oxidation which is done by the microbes. The microbe, as you know, are some organic, they are some living organisms. So the living organisms can react with the ethanol, but there is a difference here. This is also a kind of the oxidation of the ethanol, but this oxidation is not producing carbon dioxide and water. This is some different kind of the oxidation. You do not get carbon dioxide and water here in this case. Instead, the functional group of the alcohol is changed into another type of the functional group. Have you read about this functional group, C double bonded O and OH?
The carboxylic acid.
Yes, carboxylic acid. So this, you can say, this is a limited oxidation. It is not a complete oxidation. Instead, it is limited oxidation of the ethanol. As a result of this limited oxidation, you basically get functional group of carboxylic acid. So this is shown here, and this is done using the microbes. Microbes are basically microorganisms such as bacteria or yeast. These are the microbes. The compound ethanoic acid has another name as well, that is acetic acid. You should also memorize this name. The other name of the ethanoic acid is acetic acid. Is it clear?
Yes.
Okay. Now there is oxidation of the ethanol using the potassium dichromate. The potassium dichromate can also react with the ethanol. Here in this case, there is kind of a test which we can use to check the chemical nature of the ethanol. For example, here the oxidizing agent is the potassium dichromate 6 and its formula is K2Cr2O7. This is an oxidizing agent. This oxidizing agent reacts with the alcohol. The alcohol can be ethanol, propanol, butanol, anything. It can be any of these alcohols, and they react in the presence of the dilute sulfuric acid. Dilute sulfuric acid provides the hydrogen ions in this reaction. Now, the chemical equation for this reaction is shown here. This is an ethanol, and it reacts with the K2Cr2O7. Instead of using the whole formula of the oxidizing agent, they represent this oxidizing agent by square brackets and an oxygen inside the square bracket that is used to represent the oxidizing agent. Are you getting my point?
Yes.
So this K2Cr2O7 is shown by this square oxygen within the square brackets. They react with each other, and as a result, the oxidation occurs in the alcohol, and you are getting the ethanoic acid. This time, it is not done by the microbes. Instead, it is done using the oxidizing agent along with sulfuric acid H2SO4. So what you are getting from here, you are basically getting ethanoic acid plus water. So there are actually two products here, carboxylic acid and water. However, in the previous case of the microbial oxidation, you got you got only one product, that was the ethanoic acid only, and no water formation. That's why it was called as limited oxidation. But the this reaction in which we study with the reaction with the oxygen, this is called combustion as well. If you recall, we had the same type of the reaction in alkanes and alkenes. This is called combustion reaction, in which the combustion products are carbon dioxide and water. These are the combustion products, right?
Yes.
So combustion products are formed as a result of the combustion, and this is also called complete combustion or oxidation of alcohols. But they have categorized these oxidation into further types. This one is the complete combustion or complete oxidation. This is the microbial oxidation, in which we got on the ethanoic acid, and this third one includes the oxidation with the oxidizing agent. The oxidizing agent will also produce water along with the carboxylic acid, and this reaction is done under heat under reflux. The condition required is heat under reflux. The short form is HUR, but don't use this short form in your answer. Just use this, just state this three words: heat under flux. And the starting material, as we can see, are ethanol and the oxidizing agent in the presence of the dilute sulfuric acid. So there are three reactants: ethanol, potassium dichromate, and dilute sulfuric acid. Is it clear?
What do you mean by under reflux?
Under reflux is basically this. Here's the picture of this. I need to explain what this apparatus is and what's the purpose of this apparatus. For the formation of the organic compounds, we sometimes need to completely react the reactants with each other. For organic chemistry or organic compounds, we need to completely react the organic compounds with each other. Completely react organic compounds, and these react at high temperature. In this kind of the apparatus, this apparatus is used for the heat under reflux. In this kind of the apparatus, this apparatus, this shape, do you know the name of this shape, this lower portion?
No.
It is called round bottom flask. Round bottom flask. Here in this flask you have the reactants present. The reactants in this case, as you know, are alcohol and the oxidizing agent along with the sulfuric acid. These reactants are heated at high temperature, and you must be familiar with the property of the organic compounds that they can easily be vaporized. The organic compounds can easily convert into the vapor form. Is it so?
Yes.
So when we heat these compounds, then this alcohol compound, which is the organic compound here, this organic compound will easily convert into the gaseous form upon heating. And if we allow them to go out, escape out from this mixture, then will there be any reaction to be done in this flask?
What? Can you repeat that?
I'm asking that when you heat the alcohol and it converts into the gaseous state, will there be any alcohol left behind in this flask?
No.
No. So there will also be no reaction taking place in the flask, right?
Yes.
So we need to have complete reaction of the alcohol. We need to have a complete oxidation of the alcohol, and it can only be possible when this gaseous alcohol, which is going upward, must come down back into the flask. When it goes up, it will come back into the same flask, and this is done using this condenser. Have you seen the shape of this condenser before?
Yes.
What's the purpose of this condenser?
It cools down the vapors that are in the liquid again.
Yes, it cools down the vapors. Does it only cools down? Like, does it just decreases the temperature, or there's something else as well?
Condenses it.
Sorry,
Like it condenses it.
what is condensation?
Like when the vapor turns into liquid.
Yes, very good. The vapors are converted into the liquid. That's the purpose of this. That's the purpose of this condenser. The gases of the alcohols were moving upward, and this condenser helps to convert them back into the liquid, and so they go back into the flask. So this process keeps going on inside this whole apparatus, and the reaction of the alcohol is completed with the oxidizing agent and sulfuric acid. So this is done in the heat under reflux. That's the whole theme of the heat under reflux, and how the condenser basically cools down the gases. How does it do it?
There's cool water entering on
Yes,
the
yes, exactly. By the way, I think they have mistakenly shown the wrong arrow sign here. The arrowhead should go from left to right, not from right to left. Alright, there is a mistake here. The water is going inside from the lower portion. The water is going inside from the lower portion, and the water is coming out from the upper portion of the condenser. And this water flow will help to reduce the temperature of the gases, and they condense back to the liquid, and they come back to the flask, round bottom flask, where the reaction is continued with the oxidizing agent. And in this case, the oxidizing agent is the potassium dichromate, K2Cr2O7. Is it clear now?
yes.
So whenever you will see heat under reflux, you should have a clear picture of in your mind what this heat under reflux means. You must reflect this whole apparatus along with its purpose and function. Is it clear now?
Yes.
Okay. Now coming back to the topic which we have started, the potassium dichromate K2Cr2O7, basically within this compound there is a transition element, chromium. Chromium is the transition element, and I think you are familiar with the transition elements.
Not too much. Not too much.
Not too much, but you do know that their position in the periodic table.
Yes.
Okay, so basically the transition elements have different colors associated with their different oxidation states. The chromium in this has its own color in different oxidation states. This is the color of the chromium, or sorry, you can say the color of the potassium dichromate. It is the color of the potassium dichromate, and this is the color when the oxidation of the alcohol is done. This is the color when the oxidation of the alcohol is done. So basically you can use this to check the presence of the alcohol. It is shown here that a few drops of ethanol are added to a solution containing the orange mixture of potassium dichromate and dilute sulfuric acid in a test tube. The tube is heated in a hot water bath. So the left test tube or beaker, whatsoever it is showing an orange color, and this orange color is because of the presence of the potassium dichromate with the sulfuric acid. Are you getting the point?
Yes.
Okay, and when the reaction of potassium dichromate with the alcohol is done, then after that the color of the solution turns into green, and this shows that the chromium has also changed its oxidation state. Are you familiar with the oxidation state?
What?
Oxidation state.
Not really.
Not too much? No?
No, not much.
Okay. Basically, oxidation state is referred to as the charge of the atom in the compound. It is the charge. It is the charge of atom in compound. Basically, the K2Cr2O7 has a name, this potassium dichromate. Potassium dichromate and there is a bracket after this, and there is 6 inside. It is 6 in Roman number. Is it so?
Yes.
This 6 represents the oxidation number of the chromium. So we can see that chromium has +6 charge in the compound. This is the charge of the chromium in this compound. Alright.
Oh, okay.
And now when this reaction is done, the charge of the chromium becomes Cr3+. It is now Cr3+, chromium 3. So basically what you are looking at, that chromium +6 converts into the chromium +3. Can you tell me what this reaction is showing? Is it oxidation reaction or reduction reaction?
It's an oxidation reaction.
No, it is reduction reaction.
How low?
Like, sorry?
Then it losing electron?
It is gaining electrons. It is gaining 3 electrons. You should have clear idea of oxidation and reduction in terms of the electron loss and gain. Whenever we have an atom with plus charge, it gains electron and converts into the neutral form, because +1 charge of this sodium is cancelled by 1 negative charge of the electron. So as a result, the charge on the sodium atom becomes 0. It is neutral now.
Oh, okay, understood.
We do not basically represent the charge of the atom. We just ignore it. We do not write it. We only show the charges of the ions, not the atoms. In this case, it is the oxidation number as well as the charge of the sodium ion. +1 is the oxidation number as well as the charge of this sodium. In the same way, chromium +6 means this +6 is the charge or the oxidation number of the chromium, and this +3 is the charge or the oxidation number of the chromium on the right side. So basically it has gained 3 electrons, so that the plus 6 is now cancelled. 3 the 3 electrons have cancelled 3 plus charge of the chromium, and now we are left with only chromium 3 plus. Is it clear?
Yes.
Okay, so here in this reaction in which we are basically oxidizing the alcohol using the potassium dichromate, we are converting chromium plus 6 solution into the chromium plus 3 solution. Is it clear now?
Yes.
Whenever you will have a question, the question will also expect you to remember these colors. They will either ask you the colors, or they will indicate you the colors, and you will need to tell that the reaction has been successfully done. If you see a color change from orange to green, it means you have used potassium dichromate, and you should also have that potassium has plus 6 charge in the orange color, and it has plus 6 charge in the green color. Moreover, you should also know that this reaction is possible with the alcohol compound. The alcohol has shown this reaction with the potassium dichromate, because you need these two reactions to have this reaction possible. Are you getting the point?
Yes.
Okay, so this is the complete reaction shown down here. They are not using the formula of the potassium dichromate. Instead, they are representing this reaction, this oxidizing agent with this square bracket inside the this oxygen with inside the square bracket. That will be discussed here. The first way is through the fermentation process. You can produce alcohol from the fermentation. Do I need to read through this whole passage or not?
No need to.
Okay, you can just look at these equations to have the clear picture. This is a glucose molecule. This glucose is obtained from the sugar. The sugar is the larger molecule of the glucose. It is obtained from sugar molecule. Now this glucose is converted into the ethanol along with the carbon dioxide formation. This step or this reaction is called as a fermentation step or fermentation reaction. As a result of the fermentation reaction, the glucose molecule is converted into the ethanol and the carbon dioxide, and you have to memorize the conditions required for this reaction. The condition means the temperature you need, the catalyst you need, and other conditions. So temperature is 30 degrees centigrade, catalyst used is enzymes in yeast, and other condition is anaerobic. What is this anaerobic?
Without the presence of oxygen.
Yes, without the presence of the oxygen, or you can also say without the presence of the air. Both means the same thing, air or oxygen. So you just need to learn this reaction. This was the one method of producing the ethanol. Now there is another method, and this method you have already seen in the previous topic of the alkenes, in which we did the hydration of the alkenes. Remember that?
Yes.
So in alkenes, let's suppose if I draw this carbon structure of 4 carbon atoms with double bond present at this point, and I react it with the water in this case in the form of the steam gaseous state, it will give me an alcohol. What shall be the product of this reaction?
Butanol.
Butanol. Okay, so there will be OH bonded at this site of the molecule, and the rest of the carbon atoms will all of single bonded. There will be single covalent bonds between all the carbon atoms. So this is butanol. Exactly. So for this method, you have to learn that the starting materials required are ethene and the steam. Temperature required is 300 degrees centigrade. Pressure is 60 to 70 atmospheres. What is the unit of the atmosphere? What is a simple like abbreviation of this atmosphere?
Is it ATM?
Yes, ATM is also the unit of the atmospheres. Or you can say ATM is the unit of the pressure. ATM is the unit of the pressure, and its atmosphere is abbreviated by ATM. And then the catalyst. Catalyst used is phosphoric acid, H3PO4. And now here, only a small proportion of the ethene reacts. The ethanol produced is condensed as a liquid, and the unreacted ethene is recycled through the process. So you will get a small proportion of the alcohol from this reaction. There's a you can say plus or negative point of this reaction. On the other hand, for the fermentation, yeast is killed by more than about 15% of alcohol in the mixture, and so it is impossible to make pure alcohol by fermentation. The alcohol is purified by fractional distillation. This takes advantage of the difference in the boiling point between the ethanol and water. So as a result of the fermentation, you have to separate the alcohol from the mixture, and this is done using the fractional distillation, which requires different boiling points of the alcohol and the water. On the basis of the boiling points of the water and the alcohol, you can separate them. Any question from this portion of the alcohol fermentation, formation?
No, I understand.
Okay. Now you have to definitely learn these differences, because you will be assessed on this topic. What is the difference of the fermentation versus hydration? So in case of fermentation, you are basically using the renewable sources. The renewable sources include the sugarcane, sugar beet, etc., which you can basically grow in the fields. After using these resources, you can again grow them in the fields. Whereas in case of ethene, you are using the non-renewable source, which is finite. Like, which compound is the non-renewable here? Where is non-renewable source in this case of the formation? Which compound is non-renewable here?
The oil, the crude oil.
Where am I using the oil? Why I'm using the oil for hydration of ethene?
Or is ethane the non-renewable source?
Sorry?
Or like is ethane the non-renewable source?
Ethene is a non-renewable source, but this has any link with this oil? This oil means petroleum here, not this. It is the petroleum. Petroleum has another name called crude oil. Okay, this crude oil is used to form the ethene. This crude oil, petroleum, is used to form the ethene, and that's why we say that petroleum is finite in our earth, and that's why it is a non-renewable source. Then we have the type of the process: batch process versus continuous flow process. What happens in batch process? Everything is mixed together in a reaction vessel and then left for several days. That batch is then removed and a few reaction is set up. This is inefficient. So it is used for a limited time. The batch process is used for a limited time, not continuously used. On the other hand, in continuous flow process, stream of the reactants is constantly passed over the catalyst, and this is more efficient than the batch process. Any question from this point?
No, I understand.
Okay. And then rate of the reaction. The renewable source method has a slow process. It takes several days because in this case you are basically using the microbes, and microbes are slow in their movement. The bacteria and the yeast, they are slowly working, whereas in the case of the steam formation you are basically using chemicals, and chemicals can quickly react with each other. That's why it's quick. Now about the quality of the product. The fermentation produces very impure ethanol which needs further processing, and here the further processing means it is a fractional distillation. Fractional distillation is used to separate the alcohol from the mixture. On the other hand, the steam process does not require this processing, so it produces pure ethanol. And last, the reaction conditions. For the fermentation, you need gentle temperature and atmospheric pressure. What does it mean, like gentle temperature and pressure?
Where the reactions happen at like a lower temperature.
Yes, exactly. You can use a low temperature and pressure. So there are pros and cons of both the processes. So if there is any question related to the advantages and disadvantages, you can list them out from these differences. You should have a clear picture of it. Okay, so we have discussed the formation of the ethanol. Now the next portion is based on the carboxylic acids. So carboxylic acids can be shown by the functional group COOH. COOH means it has this part. Do you know the name of this part?
Double bond O.
What you said? It's carbonyl. Have you read this word before?
No.
Okay. So this is the carbonyl group present, and then this is the, what do you call to this part?
The hydroxyl.
Yes, hydroxyl. So this is the hydroxyl part of the carboxylic acid. Now you have seen that carboxylic acids can be formed by the alcohols, and they can be formed by the oxidation of the alcohols. We have just seen these reactions before. Alcohol can be oxidized into the carboxylic acids, and we've seen it through the oxidation using the microbes and oxidation using the potassium dichromate as the oxidizing agent in the presence of the sulfuric acid. So basically it is the repetition of the previous topic. Now something about the naming. How can we name some of the carboxylic acids? So just like in the previous cases of the organic compound, you have to give the names according to the number of carbon atoms present. For example, if there is just one carbon atom, then you will say it as methanoic acid, and when there are two carbon atoms, you will say ethanoic. for 3 you'll say propanoic and butanoic acids. I hope it's clear.
Yes, it's clear.
Okay, then next about the properties of the carboxylic acids. Manal, I will keep I will keep going. Then I will not be stopped. So
Yes.
okay. How do we know which one is the limiting and which one is the oxidizing which is the limiting and which is the excess reagent? For this purpose, you must convert this mass into the moles. Did you convert it into the moles?
I wasn't sure what steps you take here, so I didn't do it that way.
No, like, do you know how you can convert this mass into the mole?
Yeah, to convert it into mole, you divide it by the AR or the...
Yes. So mass is 0.55 divided by the AR of the zinc. What's that?
65.
65. So the value come out to be you need to keep as many decimal points as you can. 8461. So these are the moles of the zinc here. Now we can see there is another moles of the other reactant. In this case, that's a hydrochloric acid. It is 2.5, so I can convert this value into the standard form. It will become 8.46 into 10 raised to power minus 3. Now I have moles of the zinc and I have the moles of the hydrochloric acid, but I need to check which is the excess reagent and which is a limiting. To find this, you have to use a stoichiometry. You have to use a stoichiometry and the ratio method. Are you familiar with these two?
I think I'm familiar with the ratio method.
And not about the stoichiometry?
Not much.
Okay. Basically, what is the ratio method, by the way?
I'm not 100% sure, but like I think it would work the most in like ratios.
Okay, ratio method means you have to take the ratio of two substances here, right? You have to take the ratio of two substances. Which two substances should be used in the ratio?
Hydrochloric acid and zinc.
Hydrochloric acid and HCl. Good. So basically I have taken I'm going to take ratio HCl versus zinc. That's the first step. That is the deciding factor. It is considered as a deciding factor or deciding step, like which two substances should be compared for the ratio. This is first step, and the second step is that you have to use the values which are given in the balanced chemical equation. The values which are given in the balanced chemical equation, and those values are the stoichiometry values. You have to use the values already present in the balanced chemical equation. Here in this case, the values given in the balanced chemical equation are the moles. You have 2 moles of the HCl. How many moles are there of zinc?
1.
1. So either will be provided with the moles in the balanced equation, or you will be provided with the volume of the compounds, or you can also use their molar masses. MR or AR, but they must be multiplied with the numbers or the moles coefficients of these substances. Anyways, I'm making it simpler for you right now. You are using the stoichiometry values which are moles over here. So for HCl we have 2 moles and for zinc we have 1 mole. That's the second step. Now the third step. The third step includes the values which you are either about to find or which you are already given in the question, or you have the already which you are calculated from the previous step. The step means the unknown value and the known value. The unknown value is to find the mole of the Here in this case, the industrial adds 0.55 grams zinc to a solution containing. Oh wait, there's one more thing. You can find the excess reagent simply from these values. We have 8.46 into 10 to the power -3 moles of the zinc, and the hydrochloric acid was 2.5 into 10 to the power -2, but HCl is present by 2 moles. There are 2 moles of the HCl, and to find for the 1 mole of the HCl you have to divide 2.5 into 10 to the power -2 with 2 to find the moles of the HCl for 1 mole. Are you getting my point?
Yes.
Okay, so if I calculate this value, 2.5 power -2 divided by 2, it will give me 0.0125 moles. 0.0125 moles. So basically these are the moles of the HCl when only 1 mole of the HCl has reacted. When if I say that 1 mole of the HCl reacted. On the other hand, the calculation for the mole of the zinc came out to be 8.46. Now tell me which value is smaller or which value is greater?
The value for the number of moles of HCl is greater.
Yes, the HCl value is greater. So we can say that HCl is excess reagent. On the other hand, zinc is the limiting reagent. It is a limiting reagent. Is it clear?
Yes.
Okay, so that's how we basically determine the excess and the limiting reagent here. We just that's why there are two marks for this question. 1 mark should go for the calculation of the moles of zinc, calculation of moles of zinc, and the second mark is to calculate the calculate the moles of the HCl by dividing with it too, and also telling that HCl is the excess reagent and zinc is the limiting reagent.